Integrated rate law for gaseous reaction, first order reaction. For example, here A gives rise to B plus C. Gaseous reaction this is. All reactant and product are in gaseous state. So now T equal to 0 time, the pressure of A is P initial, Pi, product not formed, therefore dash, or you can write 0. So P total at T equal to 0 is P initial plus 0 is equal to P initial. Now T equal to some T time. At this state, this A will be converted into B plus C. Therefore, some amount from initial is loss. That is Pi minus X. Therefore, with respect to stoichiometric coefficient of the B, that is 1 mole, therefore 1x. C also 1 mole, therefore this is also x. These all together, we can say P total is Pi minus x plus x. Now, this is minus x and plus x cancel. Therefore, this is Pi plus x. This is called P total. P total. And this one is Pi minus x is called pressure at T time. Pressure at T time. Now, we know that P total is equal to Pi plus x. Now, P total minus Pi is equal to x. This is x value. Now, P at T time is equal to Pi minus x. P at T time is equal to Pi minus x place what we can place? This one. P total minus Pi. Then P at T time is equal to, this is called Pi minus into minus this Pi is called plus Pi. Therefore, I can write this is Pi plus Pi minus P total. Totally, it is represented as P at T time is equal to 2Pi minus P total. This is at T time. Then we know that first order integrated rate law K is equal to 2.303 divided by time log R naught concentration by R at T time concentration. Similarly, K is equal to 2.303 by time log. Now here what is there? R naught. in this place we can write P naught or P initial that is. This one is R at T time, therefore we can write pressure at T time. This can be represented as Pi by pressure at T time. Therefore, K is equal to 2.303 by time log Pi only, but P at T time now only we calculated, that is P at T time is equal to 2Pi minus P total. Therefore, I can write here 2Pi minus P total. This is a final rate law constant for this particular equation. What is the particular equation? A gives rise to B plus C in gaseous state. Now this rate law or rate constant equation applicable for this equation only. When stoichiometric coefficient of this reaction changes, then this P at T time also change. That's why every time we have to derive and write the rate constant for gaseous reaction. One more example I will give, then you will understand how to derive this pressure at T time. Now, before equation what I given, A gives rise to B plus C. All our stoichiometric coefficients are 1, 1, 1 is given. Now, in case if I want to take A gives rise to 2B plus C, then this is a gas, gas, gas. So we have the rate constant formula. K is equal to 2.303 by time log P initial by P at T time. Then P at T time we have to find out and place in this equation. So now T equal to 0, this is called P initial, and this is dash, because reaction not at all started, therefore only gaseous A is present, B and C are absent. Now P total is how much here? Pi, because at T time initial pressure only present, product of B and C pressure not at all present, that's why only Pi. Now T equal to some T time, this can be represented as Pi minus X. This is called pressure at T time. Now these are B stoichiometric coefficient how much here? 2. Therefore this is called 2x. Stoichiometric coefficient here 1, therefore it is called x. And here P total is Pi minus x plus 2x plus x. Then what happened is minus x plus x cancel, and then we get here P total is equal to Pi plus 2x. Now we have to get x, because why we have to get x, meaning here this x we have to get from this equation. Therefore I am separating the x. P total minus Pi is equal to 2x. P total minus Pi divided by 2 is equal to x. So now I got x. Substitute in this one. What is the equation? pressure at T time is equal to Pi minus X. Pressure at T time is equal to Pi minus X value, what is that? P total minus Pi divided by 2. This can be rearranged as P at T time is equal to 2Pi and minus P total minus Pi divided by 2. Then P at T time is equal to 2Pi minus P total, minus into minus plus, therefore plus again Pi divided by 2. Now P at T time is equal to this 2Pi and this Pi, total 3Pi minus P total divided by 2. Now we know that pressure at T time. Then substitute in this equation. This is the equation. In this we have to substitute. What is that? K is equal to 2.303 by time log. What is that? P initial divided by 3Pi, because pressure at T time, this one. Pressure at T time is equal to 3Pi minus this is P total. Therefore, I can write now P total divided by 2. This 2 will goes in numerator, that's why 2. So this is a final equation for reaction A gives rise to 2B plus C. So every time this P at T time will be changed when stoichiometric equations are changed. So every time we have to derive. One more example if you want, I will give that. One more example. Example is N2O gives rise N2 plus half O2. Gas, gas, gas. For this, K is equal to 2.303 by time log P initial divided by P at T time. So what we have to find out? P at T time find out and place in this equation. So now T equal to 0 time, this is called Pi and this is dash dash. What is here? P total? P total is Pi. T equal to some T time, this can be represented as Pi minus X. This is pressure at T time. Then here according to stoichiometric equation 1 mole is there. Therefore here 1x. Here half mole is there. Therefore half x. X by 2. Then P total is, I will write down because there is no sufficient space here. So I will write down. Now pressure total is equal to pi minus x plus x plus x by 2. Now this minus x plus x cancel, then you will get here p total is equal to pi plus x by 2. Now we have to get x value to place in this one. Therefore, P total minus Pi is equal to x by 2. Then 2P total minus Pi is equal to x. Now we got x. Place into this equation. Pressure at T time is equal to Pi minus x. Pressure at T time is equal to Pi minus, what is here? X value is this 2P total minus Pi. It meaning this is multiplied to this one also, this one also. Therefore, I can write direct 2Pi. Otherwise, I can write here x is equal to 2P total minus 2Pi. Therefore, it is 2Pi. Now, pressure at T time is equal to, this is 1Pi minus into minus, that is a plus. Therefore, that is plus 2Pi. Totally, it can be represented as Pi total 3Pi minus 2P total. Therefore, now I got the P at T time. I can place in this equation K is equal to 2.303 by time log P initial by P at T time. So placing now, and I will get here K is equal to 2.303 by time log P initial only, P at T time, meaning this is the pressure at T time, that is 3Pi minus 2P total. So every time what happened, this equation going to be changed. Therefore, for board level exam, what is given in the textbook, A gives rise to B plus C. That is enough. But for competitive exam level, every time they may ask for this equation, what is the rate constant for first order reaction. Then we have to derive and substitute. This is a final equation. So keep in mind, every time this pressure at T time will be changed according to the stoichiometric coefficient. So don't remember only according to textbook A gives rise to B plus C. So stoichiometric coefficient change for same A gives rise to B plus C. Sometimes 2A gives rise to B plus C. Otherwise A gives rise to 3B plus 2C, like this every time stoichiometric coefficient may change, then pressure at T time also will be changed. So according to that we have to find out and place into this equation. Now one more equation I am taking here. A gives rise to 3B. This is gaseous reaction. Now we know that K is equal to 2.303 by time log P initial by pressure at T time. Now I will write T equal to 0 time. This is called P initial dash. Then P total is equal to Pi. T equal to T time, then this is called Pi minus x. Then here according to its stoichiometric coefficient, this is called 3x. This will call as pressure at T time. Now pressure total is equal to Pi minus x plus 3x. In this 1x cancelled and 2x is left. Therefore, this is called pressure total is equal to Pi plus 2x. One another new thing is here, in case time is infinite. So this is called totally 0 dash and this is called 3 Pi because how much initial amount is present that completely convert into product according to the stoichiometric coefficient. So this is called pressure at infinite time. Pressure at infinite time. Therefore, we can say here pressure at infinite time is equal to 3 Pi. And in this case, I can write Pi is equal to P infinite by 3. One equation, it will be useful later, so you have to remember this. Now, by using this equation, what is that? Pressure total is equal to Pi plus 2x. Separate the x term, then pressure total minus Pi is equal to 2x. Then pressure total minus Pi divided by 2 is equal to x. This is called x and substitute in this equation. What is this? Pressure at T time is equal to Pi minus x. Pressure at T time is equal to Pi minus this x is known as a P total minus Pi divided by 2. This can be rearranged as, then this will be multiply this 2Pi minus P total minus Pi divided by 2. Therefore, now P total is equal to, this one is called 2Pi minus into minus plus, therefore total this is 3Pi minus P total divided by 2. What you call this is pressure at T time. Now we know that pressure at initial time is, that is called P infinite by 3. We will substitute in this equation. So keep in mind 3Pi minus P total by 2. So now we know that pressure at T time, pressure initial. Then we can substitute in this equation. Pressure at T time is equal to 3 Pi plus I can write P infinite by 3 minus P total divided by 2. Now in this place Pi, I place this one P infinite by 3. Then this is cancelled. Then we can write P at T time is equal to P infinite minus P total divided by 2. Now we got pressure at T time. Now We know that K is equal to 2.303 divided by time log P initial divided by pressure at T time. Now K only, that equal to 2.303 divided by T log Pi place. We can write this one. What is that? P infinite by 3. This P at T time place we can write this one. That is what P infinite minus pressure total divided by 2. The 2 will goes numerator. So this is a final equation when P at T time and P infinite given. First we have to calculate separately P pressure at infinite is equal to how much and pressure at T time how much, separate calculate. Then pressure at infinite we have to place in the pressure at T time. Then this type of equation we will get. So this is also every time change according to stoichiometric coefficient. I hope you understood, and these are important for NEET and JEE mains level. For board level only one equation important, A gives rise to B plus C according to textbook.